Welcome to the first video of our Power Tools Studio series. This video we're going to be talking about how to set up motors, which is the first step on setting up any Power Tools application. And no, we're not talking about power tools like the kind you hold in your hands and build stuff like sheds and garages and cool things like that. No, we're talking about Power Tools, the software, which is used with the PTI 210 module for the Unidrive and Digitex HD drive lines. Now in this video we're going to be covering things like setting up an induction motor, we're going to be setting up a servo motor, we're going to be setting up an encoder, we're going to set up the thermistors, and we're going to do a rotating autotune on the motor to show you what that looks like. If that sounds like something you would like to learn about or need some help with, continue to watch the video. Else, go watch something funner. So we're going to be using a software tool called Power Tools Studio. It looks almost identical to the old software called Power Tools Pro, except they've added some features to it and it's been designed for the newer drive lines. So if we come up here to File, you will see the option to make a new project. So we're going to make a new project. If you look at this window that just opened up, you can see that there are two drive families that this software supports. The first drive family it supports is the Unidrive M, and the second drive family it supports is the Digitex HD. Now if you're using a Unidrive SP or an older drive platform, then you still need to use Power Tools Pro. Now for everyone who's not used to Power Tools, that's okay, you're in the right spot. We'll be covering everything so easy that anyone can follow. So in today's video, I will be using a Unidrive M700. So I'm just going to select it right there and then hit OK. The next thing we need to do is set up the type of motor we're using and the type of encoder we're using. To do that, we go under Hardware. And if you look right to the left side, there's these little arrows. And if you click on it, the tree expands. And the first thing you see is Drive, Encoder, and Motor. If you click on this, you will see that there is a new window open up and there's a bunch of things to select from. The first thing you need to do is select what drive you have. So my drive is the very first one on the list. That typically isn't the case, so you need to make sure you select your drive that you're going to be using the software with. Now you're going to notice that the part number isn't completely here. Remember we selected that it's an M700. Well, this is the second part of that part number. So it's an M700-0320050. And so that is my complete part number. The next thing we need to do is select what kind of motor it is. Now, that has to do with the drive mode. If you look right here, there are two different drive modes, RFCS and RFCA. You're probably expecting to see something like servo motors or induction motors. But in the software, it's talking about the actual mode inside the drive. But this is basically what this is. RFCS is for synchronous motors. A servo motor is synchronous, and therefore that's what you would select. RFCA is for asynchronous motors. Induction motors are asynchronous, and therefore this is the mode you would use. Now, we're not going to be setting up an induction motors for reals, but I would like to walk through the process. So once we've selected RFCA for induction motors, you then will come over here and select your motor. Now you're going to see that there are no motors in this induction motor list here for us. So what we need to do is come down here where we stop using the motor database and we uncheck it. This will allow us to put in a custom motor, and we will be able to save this custom motor to our motor database so that we can use it in the future. To do that, we need to make sure we put the correct part number here. So this would be the full part number of your induction motor. You would then go through all of these inputs and populate them to the best of your ability about the induction motor. Now most of the time, we don't need to do everything here, but we do need to do the following. We need the peak current that you're allowing the drive to put out. We need the full load or the FLA of the motor. We need to know what voltage the motor is rated at. we need the number of poles, and we need the rated frequency of the motor. Typically this is 60 Hertz, but that's not always the case. You also need to give it the rated speed, that's right here, and the max operating speed. Well, typically it's never 1800 RPM. So if it's a 4-pole motor, quite often it's like 1750. Right? That's typically the actual slip speed of the motor. That's what you would put here. And the max operating speed is the max speed that you want the system to actually run to, which is typically 1800 RPM or whatever the motor's good for. Down here is the power factor. The power factor is very important. You would put the power factor in here if you want the full torque of the motor. Now, with that said, if you don't know the power factor and you can do a rotating autotune, well, you can use the rotating autotune to find the power factor for you, but it has to be a rotating autotune. So please be cautious there and take mind that the motor will go pretty fast. Down here below, you will see KT. You don't have to put KT in here. It's nice, but it's basically the amount of torque per amp. It helps the drive out, but it's not necessary. The induction and the resistance values, the autotunes will find for you, so that's good. And the saturation breakpoints, this autotune can find those too for you. So for the most part, you're going to give it the current, the voltages, the number of poles, and the power factor and the rated speed. That's really what you need to put in here. And the other thing is you need to set up the encoder, which is over here. Now we're going to be covering this a little bit later because we're actually going to set up a servo motor for real. So just mind that that's how you set up an induction motor. So if we go to RFCS, we're going to actually set up a servo motor. You're going to see that the list is far smaller with a servo motor than with the induction motor. And if I didn't have a Control Techniques motor, again, you would check this off to say I'm not going to use the motor database that's provided with Power Tools Studio. In my case, I am going to use a motor from Control Techniques, so all I have to do is come up here and find my motor. In my case, my motor is right down here, 067 EDA300. Okay, so once I selected that, all of the values here changed to the appropriate values. Now I'm going to do a rotating autotune, which will be a very slow turn for a servo motor. It's not for an induction motor, but for a servo motor, it's really slow. And what it's going to do is going to find the true phase angle, and it's going to adjust the resistance values and everything. Okay. Now, one thing that selecting this motor part number does not do, it does not set up the encoder. So we still need to come back to the drive encoder P1 and actually tell the software what encoder our motor has. So I click over here, and by default, it thinks it's an incremental AB type servo motor, and it's not in my case. I am using an indat only. Now with indats, I like to move the baud rate up to 1 megabaud, and maybe even 2 meg, but 1 meg's pretty good, so that's where I'm going to leave it. If you were using sine cosine indat, then the default value is plenty fine. Okay. The other thing you need to do here is select the correct type of thermostat that you're using for your servo motor. You can see that by default there's this weird thing called DIN 44082. That's technically a spec. Basically what it means is that the thermostat acts kind of like a light switch. It basically has a low resistance when it's happy, and it goes to a very high resistance when it's too hot. So it kind of acts like it's you're opening a contact or something like that. Now you can also see that the drive supports a KTY84 and something called encoder. Now a lot of indat encoders or indat motors that come from Control Techniques, you will have the thermistor data coming over the indat channel, and so this is what you would select. Now for me, I don't have that. Matter of fact, my encoder is not even wired up, so I'm going to disable the trip here. Otherwise, once we download, it's going to immediately trip on a thermistor because the thermistor won't be seen. So I'm going to turn that off. Now if you do have a thermistor of type DIN 44082, which is basically like a switch. It doesn't actually give you a temperature. Down here at the bottom, there is the thresholds for the trip and the reset. So basically, if the resistance goes above 3300 ohms, then the drive will trip, and it will auto reset when the resistance falls below this, which means that the motor is now cool enough to run. This is technically used with even the other modes, like an encoder mode, because technically what comes over the encoder channel is a resistance. Same thing with a KTY84. It is also a resistance. It's just that it's linear, and so you can convert resistance into a temperature. But again, I'm not using any of that. Now that we have that all set up, the last thing we need to do over here before we actually download and do an auto-tune is we need to make sure that we put the PTI 210 in the appropriate slot. You'll notice over here there are 3 slots. Slot 1, slot 2, slot 3. Some drives only have 2 slots, other drives have 3 slots. We need to tell the drive which slot that it's going to be in, because if we lie to it, then weird things are going to happen, like you're not going to be able to log on to the drive. In my case, I have the Power Tools module in the bottom slot, which is slot 3. So I'm already set up. So the next thing I need to do is I can save it and then go to Device and go to Download. This little window comes up, which is the network scanner, and it will find all of the drives that it's seen on the network. If you have problems with this, then what you need to do is come to Settings and select a different way of scanning for that drive. For example, scan a local network basically sends out a message saying, hey, where are you at? And they respond. Where scan and network range or an address range, basically you set the range of IP addresses that you want it to go scan, and it goes and pings all of them until it finds them, and then it negotiates like that. For the most part, I always use scan a local network. You also might need to select which networks you want to actually scan. And for me, I only have one Ethernet connection, and it's called Ethernet 3. Some people will have wireless and a whole bunch of stuff that you don't want it actually scanning. So select what you want it to scan and then hit apply. So after you've found your drive or drives, you click OK. Now in this new window that opened up, you will see that it again has the same data as the previous, except it also gives you a little bit more information. Go ahead and select it and then hit OK. It will immediately download to the drive if the drive is disabled. Now if the drive is enabled, you will get a warning message. That warning message will prevent you from downloading, and you'll have to do the routine again where you go and scan for the device. Now, after you've downloaded to the drive, in the bottom right corner, it will show connected. You can see over in the left corner, the drive is disabled. So the last thing we want to do in this video is actually do a rotating auto tune. So I come back over here to Drive, Encoder, and Motor. You'll notice that there's a new tab here called Online. If you click Online, it will give you some information about the drive's encoder position. So I'm going to turn the motor by hand, and you will see that the data changes. If you come over to Motor, you will notice that there are a couple buttons that aren't grayed out anymore. One being this Apply button and this Auto Tune button. So now we're going to do a rotating auto tune. So this little window comes up with a bunch of cautions. It has the steps in order to do an auto tune here. It only lets us select an auto tune mode number 2, which is a rotating auto tune. So if you have a mechanical brake, you need to make sure that's released. You need to make sure that you can freely move the motor, and go ahead and read the rest of this. So to proceed, what we're going to do is we're going to hit proceed. So this message comes up telling you need to use the safe torque off input to cycle the enable in order to get this auto tune to run. So we're going to hit OK. So you'll notice that the proceed button grayed out and the cancel button grayed out. It is at this point that you need to enable the drive. I've just enabled the drive. The motor is turning at 1.5 RPM for my motor. It's going to be a little different depending on the motor, My motor is a 10-pole motor, so it's pretty slow. If you have an 8-pole motor, it'll be a slightly faster motor as far as the rotation. All right, now you see that the screen automatically disappeared. That means the autotune has completed. The question is, was it successful? Well, if you look on the drive, you'll see that the drive is not tripped, so it was successful. So at this point, you would disable the drive, and you can look at the values from drive. These are some of the values that it found from the autotune. It found the resistance of the motor. You can see it's slightly different. The inductance of the motor is slightly different. And the phase angle is crazy different. That is because technically my motor is not wired correctly. Now that we have our new values from our autotune, we can choose whether to use these new values in our configuration. And if we want to keep these values in our configuration, we would push the Apply to Config button in the middle of the screen. It's at this point that I typically save my project to my computer so that I have a copy and don't have to go through that anymore. I hope this was of some help, and if you have any questions, please note them in the comments below. Welcome to the end of the video. If you like this video, please watch this one right there. Not that one, watch that one. I don't know why. Whatever it is, just watch it. See you next time.